Hey, g'day guys, it's Calvin from the Cartoon Company in New Zealand. I do a heap of 1UZ conversions, wiring, and conversion related work. Today we're going to talk about the rear wheel drive transmissions on the back of the 1UZ engines, specifically the A341. Different markets have different transmissions. So we have the A340, which is pretty common in the Supras. Some rear-wheel drive Tundras have them, and there's also a four-wheel drive version, so there's a difference between the A340F, 340H. Then we have the 341, which is what we're going to talk about today. The 342, which is a kind of a variance of the 341. They're all very similar. And then there's the 343. We see that one in the Surf as a four-wheel drive transmission. Other vehicles that run this series of transmissions, you might find them in Isuzus. Some Mitsubishis have a very similar transmission. And Volvo, that was it. Volvos have a very similar transmission as well. The reason I'm talking about the 341 is that's what we see the most over here in New Zealand. And this video came about because I'm going to be converting this particular transmission to a four-wheel drive transmission. So that's the next video. We're going to use an A343 Surf chain-driven transfer case to do that job. So let's look at the transmission. So here's the A341 LE. On the side of the transmission, we have these numbers, and it says model number 3041LE. And that's the easiest way to see what you've got. If it is a 340, it'll be a 3040. A 342 is a 3042, and a 343 is a 3043. You can often tell if they're four-wheel drive or two-wheel drive by the output shaft. That's just your common sense. So the main body is very similar on them. Some of the four-wheel drives have the shifter out the other side, comes out of there. We have speed sensors. We have the overdrive speed sensor at the front. That's reading the turbine speed. Also, some people might call it the lockup speed sensor. They're just a small 2-wire reluctor type sensor. As we come down the transmission, we have the solenoid plug. There are differences there. And we'll go into those differences in just a moment. This one, as you can see, has 6 pins. And then we have a tail shaft. So I have this tail shaft. And I have this tail shaft. And this is where we get some differences as well. This tail shaft is an early one. We have a speed sensor at the front. So that is the main speed sensor going back to the ECU. There it is there. So that features on both the early and the late output housings. If I turn it over, this one, nothing in there. Where this one has a speed sensor in it. Inside the back we have a trigger ring. It's actually a later model trigger ring. Then after the rear housing, we have a drive flange. Drive flange looks like that. That is a non-VVTi drive flange. And that is a VVTi drive flange. We've got here The VVTi is an A650, and funnily enough, Toyota put 3550 on the box, and we call it an A650. Go figure. So that is the output shaft of a non-VVTi. Beyond that, so here we have one. We have a rubber donut. Just to make life fun, there are some different rubber donuts for them. They are not all the same, and they're not all interchangeable. And we see them quite normal to be damaged when they get cut off, gas axed off in Japan. Rear flange donut isn't going to work with a live rear axle. So I make up and sell this flange unit that allows it to have a normal drive shaft bolted on, like a four-wheel drive shaft with a slip joint in the drive shaft. So already, as we've talked about, we've got differences in the rear housing with speed sensors and solenoid plugs. Now I see this a lot. People say, can I interchange transmissions? What transmission have I got? Or I need a transmission. Or this, I've bought a transmission and bolted it in and it won't fit. The plugs don't fit up. The 341, they can all be interchanged quite safely. If you're swapping the old transmission out, you just have to match it up, the new one, with what you took out. The difference, rear housings, solenoid plug. Once you swap those, they're the same gearbox. So we're going to look at the solenoid plug first. Now in the early A341, up till around about 92, they had a 6-pin solenoid plug. After that, they changed to an 8-pin. So still in UCF10, but they went to the 8-pin solenoid plug. And the difference is they added a gearbox oil temperature sensor. So that's actually on the loom, and it will interchange when you swap the loom out. So that's the 6-pin. That's a 6-pin. Going down the 6-pin, we've got plugs for solenoids with single wires. So those are the two shift solenoids. And then we've got the plugs for the line pressure solenoid and the lockup solenoid. Here's an 8-pin. It's actually on my test loom. 8-pin plug. The extra one that's added is that oil temp sensor in that sits in the oil and just clips in. You pop this pan off. You may also find different oil filters for them. So there are some variances. I got this filter kit here, and it says A350E for LS400, GS300 from 96 on. The gasket, because the gaskets interchange, is the correct one. So I've gone through and I've marked the solenoids. So this is shift solenoid 1. This is shift solenoid 2. And they do the gear changes. Going down here, we have solenoid 4, which is the line pressure solenoid. SLN for line pressure. And then we have the lockup solenoid, SLU. U for up, lock up, S lock up. And that's solenoid 3. So the line pressure solenoid is solenoid 4, and the lockup solenoid is solenoid 3. Line pressure. That has something to do with this here kick down cable. Man, that makes me mad. This is not a kick down cable. That is the line pressure cable. So it's very important that that's connected correctly. If you tweak it up a little bit, it will give you sharper shifts. And then what happens when the transmission is shifting, it sends a signal, a duty cycle to that solenoid, and it reduces line pressure on shifts, making it for a nicer shift. My manual shift box doesn't use that solenoid. We don't care about nice soft shifts. We want it to shift, we want it firm, we want it to work. The lockup solenoid controls the lockup in the torque converter. Something I see quite a bit of on these is with the torque converter and the way it fits into the transmission, there are some differences in the input shaft. So the likes of if you're putting an A43 behind a UZ, guys go slip the torque converter from a UZ into it, and it doesn't contact properly on the splines, doesn't drive the oil pump properly, or it just strips the oil pump off. So make sure you confirm your shaft length. Not sure I should be saying shaft length to guys. We normally a bit personal about our shaft length. But if you've got a 343, there's a chance that you've got a shorter shaft than if you've got an A341. So check your shaft length. One solution for that with different variances like the Mitsubishi is you take the 4-speed front pump and front shaft and you can slip it in with the front clutch packs into those boxes. So either the Mitsi box or the 343 will accept the 341 input shaft and front pump and clutch pack. So solenoid 3, solenoid 4, solenoid 2 and 1. So 1 and 2 solenoids do the shifts. If you want sharper shifts, one of those is likely to solve your problems. If you're in Australia, there's a couple of places in Australia that do different kits for them. Great way of solving poor shift quality. And now it's going to rain. I'm in a tin shed. It's going to sound like a tin shed. Oh, flex plate. One UZ flex plate. Make sure that you bolt it on the correct way. You can see here, well I can see here, there's marks where the torque converter used to bolt. So it goes that way onto the back of the engine. There is a spacer plate that goes on the engine side, and that plate goes on the outside on the gearbox side, and then the bolts go through it. So it's really raining quite heavy. I'll talk to you soon once the rain calms down. Okay, so the rain stopped and we can continue. And hopefully I don't double up on everything. So the shift solenoids, shift solenoid 1 and 2, they are responsible for all the shifts, hence the word shift solenoid. The action that they have is for first gear you have number 1 on. For second gear you have them both on. For third gear you have the number 2 on. And for overdrive they are both off. And this allows for some diagnostics of the gearbox as well, and action with the shifter. So this is a Hilux shifter, which works just fine on this gearbox. It has locations within the shifter to stop it moving too far and for each gear. And if you're using a different shifter, and even if you're using the correct shifter, it does pay to check that they line up perfectly with the detents in the transmission. And you can feel it on the side. So I've brought it all the way back here to park. And you can see here with these spots that hold it into place, and that defines where that plunger sits and which gear it is in. That's park, that's reverse, that's neutral, drive, 2 and low. The gearbox has mechanical override. So if you put it all the way back on the shifter into low, you should only get low gear. When you push it into 2, it only gives it low in second. However, if you have the solenoid plug unplugged, so the solenoids aren't connected, that will shift it. Low will give it low, second will give it second. However, when you move it to drive with no solenoids, you will get overdrive, because this fault is the 2 solenoids aren't working. So you've got mechanical override in first, second, and then overdrive. You won't get third gear. Some guys think just by not connecting it up, that's manual shifting it. They move the shifter, they only have 3 gears, and they don't have a lockup. I see it very, very important to check the adjustment so that your shifter lines up with the positions on the side of the transmission. Very, very important. The little lever on the side, there is a rubber bush. That bush gets old and floppy. I do recommend changing it. And same as the one on the bottom of the shifter. On the side of the transmission, and this is on the right hand side, we have the shift selector switch, inhibit switch. They actually refer to it, I believe, as a combination shift and inhibit switch. So the small one has 9 pins, 2 big ones which are the start inhibit, and then the gears, and a power supply, of course. And then the bigger one has 2 big ones which are the start inhibit, 7 small ones which are the gears, 6 gears plus your power supply. And they need to be adjusted correctly. There is a little bit of adjustment to get it bang on so that the start inhibit switch is engaged when it is sitting in park and neutral. So lots of people aren't aware that the start inhibit switch, the bit that stops it from going when you crank it, when it's in any of the gears or reverse, comes from the transmission. And that's all done in that little switch. The next difference we see is that rear housing. So the early ones had a 6-pin solenoid plug. Around about 92, 9th month of 92-ish, but depends on models. Saurers, they went with the 6-pin much later. They changed to the 8-pin solenoid plug. They kept the same rear housing though. So it has 2 speed sensors on the rear housing. And then in the Gen 2 engines, they had the 8-pin solenoid plug, but they dropped the extra speed sensor. It's just blanked up. So they ran it off the one on the side of the transmission, just the single one. In that era, they changed the sleeve at the back, and they put one that was smooth without the gear on it, because they didn't need it to run a gear drive to run that speedo drive. I really like the Gen 2 engines when I'm wiring up autos. The reason being they only need the 1 speed sensor input to the ECU. All of the early ones, they had a 2nd speed sensor signal coming from the dash. So they had one from the rear housing, and then the speedo signal went up to the speedo cluster, got modified, came back to the ECU. So without that, they don't drive as quite as nice, and they often throw a fault code. So that's why the Gen 2s are preferable when you're doing an auto conversion, because they don't have that. The problem you have then is you need to run a speedo. For guys that are running a cable speedo in that situation, the trick is to get an early model rear housing, swap it all over, and run your cable drive in the back hole, and the front hole of course goes to the speed sensor going to the engine ECU. No fault codes, easy swap. Also, if you're doing a vehicle that's a little bit different, like an MX-5 for example, and you can then put in an electronic speed sensor in the back hole of the early housing when it's fitted to the later model ECU, and you get a separate speed sensor, makes it really, really easy. Otherwise, there are options for getting signals either out of the ECU, the SPD terminal output on the Gen 2 ECUs, or you tap into the speed sensor going into the ECU through a modify box and then off to your speedo. If you want to change your loom for your transmission, it's really, really simple. You pop the pan off like I have behind me, undo the 10mm bolt holding the loom in, unplug it, and it just feeds out, and you can feed the other one back in. So this bolt here, loom comes out, it looks like that, and you can replace it, swap it over. I also have here a couple of ECTs. So there's a 2LTE ECT, there's a 1KZ ECT. They are the control units on a couple of the diesels. The 1UZ, except for the early 131 Crown, have the ECT inside the main ECU for the engine. It's not a separate unit, it's internal. The diesels, however, run a separate external unit. Often what happens when they're wired incorrectly, they go into default mode. So you end up with a really quick second shift. So it goes first, pretty much into second, straight into third. And that's default. And that's because it doesn't have the correct load signals. So it's important they get the correct load signals if you're doing these conversions, because they are an electronically controlled transmission. So a little bit about the oil feed on this particular transmission. And I'll cover this more when I convert it to four-wheel drive. There's a hole there. Comes out via the speed sensor, and it comes up through the splines. Tiny wee hole. Tiny wee hole. And then from the tiny wee hole, there is some oil getting fed all around this rear bearing, and a portion of it can come through down these holes in this bearing. So when you're putting this rear bearing in, make sure you put it in the right place, and that allows it to then drain back through that rear bearing. It's all held together by the big nut on the back, and don't forget the shim. There's a shim in there, so it's all stacked correctly. Now in the conversion to four-wheel drive, the Surf, the A343, has the oil out the end of the shaft, out of a little frost plug that's been pushed in there. So when people just cut the shaft off, often the rear bearing ends up starving. So if you want to know more about that, watch my four-wheel drive conversion video that I'm about to do on this transmission right here. On some of this range of transmissions, you can get this little adapter that goes onto the oil lines and allows you to put a temperature sensor or a temperature switch into the line quite easily. And of course there's the lines on the side here which go off to the cooler. Running a good cooler on these transmissions is pretty important. The factory one is in the bottom of the radiator. However, often we fit an aftermarket transmission cooler. The recommended oil is a type 4, and that is reasonably important. When you're doing a conversion on one of these, I highly recommend preparing the transmission correctly. Pull the pan off, check the magnets in the bottom of the pan, check that the filter is clean or replace it, and a new gasket. And that should give you a much better life on your transmission. And likewise in the factory car, regular services will extend the life of that transmission. So I think that's about enough for now. I hope that's been somewhat helpful. I'm going to get in and convert this transmission to four-wheel drive. We'll talk to you again. Catch you later.